What if I told you that somewhere in the universe, there are places where time stops making sense, where space collapses in on itself, and where the laws of physics as we know them completely break down? Places so extreme that even light can't escape. Places we can see from the outside, but can never truly look into. I'm talking about black holes. And today, we're going to ask one of the most terrifying and fascinating questions science has ever faced. What really happens inside a black hole? Black holes aren't science fiction. They're real. They exist. We've detected them. We've photographed their shadows. We've watched stars get torn apart by them. And yet, when it comes to what happens beyond that invisible boundary, even the smartest scientists on Earth have to admit something uncomfortable. They don't fully know. From the outside, a black hole looks almost calm, invisible, silent. But don't let that fool you. A black hole is one of the most violent objects in the universe. It begins when a massive star dies. When that star runs out of fuel, it can no longer hold itself up against gravity. And in a final moment of collapse, the star crushes itself into something impossibly dense. Gravity wins. Completely. What's left behind is a region of space where gravity becomes so strong that nothing can escape. Not matter. Not energy. Not even light. That boundary is called the event horizon. And once something crosses it, it never comes back. Now here's where things start getting strange. If you were watching someone fall into a black hole from a safe distance, you'd never actually see them cross the event horizon. To you, they would appear to slow down. Their movements would become sluggish. Their image would stretch and fade. Over time, they would seem frozen in place, slowly disappearing into darkness. From the outside, it looks like they never fully enter. But for the person falling in, something completely different happens. They don't feel frozen. They don't see themselves slow down. From their perspective, they fall straight through the event horizon without noticing anything special at that exact moment. No wall. No sudden shock. No dramatic flash. Just crossing a point of no return. This alone should tell you something important. Reality behaves differently depending on where you stand. As the fall continues, gravity becomes stronger and stronger. And then comes something scientists call spaghettification. It sounds funny, but it's anything but. The gravity at your feet becomes much stronger than the gravity at your head. Your body is stretched vertically and compressed horizontally. You are pulled apart atom by atom. Not instantly. Slowly. Painfully. Until your body is no longer a body at all. But even that might not be the final story. At the very center of a black hole lies something called a singularity. A point of infinite density. Infinite gravity. Infinite curvature of space-time. According to our current understanding of physics, the singularity is where everything breaks. Space and time collapse into something we can't describe. Inside a black hole, time and space swap roles. The future becomes unavoidable. Just like you can't stop yourself from moving forward in time, inside a black hole, you can't stop yourself from moving toward the singularity. It's not a place you go. It's a moment you fall into. And this is where science hits a wall. Our two greatest theories of the universe, general relativity and quantum mechanics, do not agree inside a black hole. Relativity predicts infinite density. Quantum physics refuses to accept infinities. Somewhere inside that darkness, our understanding of reality fails. Some scientists believe that inside a black hole, matter is crushed into the singularity and destroyed completely. Others believe information is not destroyed, but stored in ways we don't yet understand. This is known as the black hole information paradox, and it has confused physicists for decades. If information is truly lost, it breaks one of the most fundamental rules of physics. If it isn't lost, then where does it go? One theory suggests that information is encoded on the surface of the event horizon itself, that everything that falls in is somehow stored on that boundary, like a cosmic memory. Another theory suggests that black holes may eventually release information through a process called Hawking radiation. Hawking radiation is one of the strangest ideas ever proposed. According to this theory, black holes are not completely black. Over incredibly long periods of time, they slowly lose energy. They evaporate. Given enough time, even the largest black hole could disappear completely. But here's the terrifying part. If a black hole evaporates, What happens to everything that fell inside it? Was it erased? Or transformed? Or transferred somewhere else? Some scientists believe black holes could be gateways. Not wormholes in the movie sense, but connections to other regions of space or even other universes. This idea is highly speculative, but it comes from the math itself. When equations stop making sense, new possibilities appear. There's also the idea that black holes may contain entire universes inside them, that what we see as a singularity could be the beginning of something else. Another Big Bang, another reality. If that's true, then our own universe might have been born inside a black hole. Think about that for a moment. What if the reason we can't see inside a black hole is because what's inside isn't meant to be seen from here? What if crossing the event horizon is not the end, but a transformation beyond our perception? Now let's talk about time again, because black holes don't just bend space. They twist time itself. Near a black hole, time slows down dramatically. The closer you get, the slower time moves relative to the rest of the universe. To someone falling in, their clock ticks normally, but to the outside universe, they appear frozen. This means that in a strange way, falling into a black hole could allow you to witness the future of the universe unfold and fast forward until you don't survive to tell anyone about it. Inside a black hole, the concept of after becomes meaningless. There may be no future in the way we understand it. Everything leads to the singularity. And beyond that, physics is no language. Some scientists believe the singularity may not be a point at all. It could be a region, or a transition, or something we haven't imagined yet. Quantum gravity, a theory we haven't fully developed, might one day explain what really happens. Until then, black holes remain the universe's biggest question mark. What makes black holes so disturbing isn't just their power. It's what they represent. They are places where certainty ends, where prediction fails, where human understanding reaches its limit. And that's uncomfortable. We like to believe the universe follows rules we can eventually master. Black holes remind us that some rules break under pressure, that some answers may always remain out of reach. But black holes are not just cosmic monsters. They play an important role in shaping galaxies. Supermassive black holes sit at the center of most galaxies, including our own. They influence star formation. They shape cosmic structure. Without them, the universe would look very different. In a strange way, black holes are creators as much as they are destroyers. So what really happens inside a black hole? The most honest answer science can give right now is this: we don't know. Not completely. Not yet. And that's what makes them fascinating. Black holes sit at the edge of knowledge. They challenge our understanding of reality itself. They force us to confront the possibility that the universe is far stranger than we imagined. And maybe that's the real lesson. Not that black holes are terrifying, but that the universe doesn't owe us clarity. It doesn't owe us answers. It invites curiosity, rewards humility, and reminds us that mystery is not a failure of science. It's the reason science exists. Inside a black hole, reality may end, or it may begin again, or it may do something we don't yet have words for. And until we find out, black holes will continue to stare back at us from the darkness, silently asking the same question we ask them: how much of the universe are we truly ready to understand?